Being situated in the North Savo region of Finland, known for its milk and beef production, the focus of our research here in Luke Maaninka Research Station is on understanding the sustainability of the milk sector. We use different scientific methods to understand the impacts of grassland and livestock management research. My research expertise is in understanding the carbon and nitrogen cycling in grassland primary production using the Eddy covariance technique. The Eddy covariance technique measures greenhouse gas exchange from a large area all year round. In the Maaninka region, we are measuring the greenhouse gas exchange from 3 different grassland types. Anttila is a research site on mineral soil cultivated with legume grass mixtures. Särkisuo and Pappilansuo are the drained peat soils cultivated with cereal grass species. We have agricultural Eddy covariance stations installed in other regions of Finland such as Ruukki and Jokioinen also. Such continuous multi-year, multi-site measurements are very essential for understanding the climate change and farm management impacts. These data are very much needed in developing best management practices to farmers for mitigation and adaptation. Also, such data are very useful as inputs for calibrating and validating various agroecological models.
Together with my colleagues, we are using static chambers to measure greenhouse gas emissions, including carbon dioxide, methane, nitrous oxide on grass rotation across both mineral and drained peat soils. The process is simple. We place a small chamber over a patch of soil or grass. By measuring the greenhouse gas concentration change inside the chamber, we are able to quantify amount of greenhouse gas is either uptaken by the soil and grass or released to the atmosphere. This approach helps us to understand how greenhouse gas emissions are influenced by factors like climate and grassland management practices, such as plowing, fertilization, and water table control. It also allows us to characterize spatial variability and identify hot and cold spots of greenhouse gas activity in the grassland ecosystem. We also investigate the carbon and nitrogen cycling in the soil, as well as soil microbial activity and function. We are trying to understand the mechanisms driving greenhouse gas emissions. For a comprehensive view, chamber measurements are ideally paired with Eddy covariance fluxes. This combined approach helps us to develop sustainable grassland management practices, making grass-based dairy farming more environmentally friendly while maintaining productivity.
In today's world, understanding the relationship between the soil, plant, and atmosphere are very important for sustainable agriculture and environmental health. To understand these complex phenomena, models are developed. Models are simplified representation of a system used to understand and predict real-world outcomes. With these models, we can predict how soil and crop respond to inputs like fertilizer, irrigation, and soil amendment, and project their effect on soil, health, yield, and environment under various climatic scenarios. While the field experimentation takes expensive time and resources, models provide efficient and valuable insights. They enable site-specific management, optimizing the resource use to maximize the yield while conserving the soil carbon, opening opportunities for the farmers to earn carbon credits through sustainable practices. These models also help policymakers to design incentives that promotes resource conservation, reduce emission and enhance food security.
Tutkimusinsinöörinä tehtäviini kuuluu kasvihuonekaasulaitteistojen ylläpito ja kalibrointi. Huolehdin niiden saumattomasta toiminnasta Suomen ankarissa ympäristöolosuhteissa. Erityisesti pyöräcovariance-laitteet ja kammiomittauslaitteet ovat alaani.
One of our project in Antilla site is to test whether red clover promote antidote reduction or not. To test this hypothesis, we are combining state-of-the-art stable isotope techniques and molecular biology techniques in both laboratory and field conditions. We are trying to assess N2O consumption phenomenon in both above ground and below ground compartment of our ecosystem. Legumes in a grassland is already a benefit for our farmers because it is a free source of nitrogen, reducing the demand of synthetic nitrogen fertilizer. Therefore, it could be an additional benefit if the same ecosystem can support N2O consumption, favoring the sustainability of our beef and dairy industry.